Hello, I'm Ebru Altan. I'm a PhD candidate at Yıldız Technical University. Today I'll present you lean construction scheduling. I'll start with lean concept and lean construction briefly and go on with lean construction scheduling, explaining the concept, comparison with traditional methods, developed methods, implementation, challenges, benefits, human factor, and social aspects. Lean methodology was created in manufacturing industry in Japan for the purpose of improving production performance. System is viewed as a whole and focuses on improving relations between parts rather than individual areas. Lean is a philosophy that should be applied systematically and integrally to all the processes in an organization to attain best performance. Lean may be viewed as a goal where its implementation changes the way an organization operates, striving for continuous improvement. Koskela challenged the construction industry in 1992 by studying the adaptability of this manufacturing concept to construction and project delivery. Core principles underlying the philosophy are eliminating waste and variability, defining value from client's perspective, defining the value-adding and non-value-adding activities, making the value-adding steps flow uninterruptedly, making what the client pulls quickly and when it's needed, and continuously improving for pursuing perfection. Lean construction goes beyond the goals of meeting budget, schedule, quality, and safety to improve the overall process by adding value to the customer and reducing waste and risk. The tools used for project management on construction sites mainly focus on planning. Construction work is generally planned by specifying activities, their durations, their assigned resources, and forming dependency relationships between these activities. When executed, these activities are expected to start at the earliest time possible with the assumption that all resources assigned to them will be available. However, a pull-driven approach that aims to produce products in an optimum time, optimum cost, and optimum quality improves the performance of construction process. Lean construction scheduling focuses on improving plan reliability by generating constraint-free tasks and short-term plans to address the problem of separation of execution from planning. Main purpose is delivering value while waste is eliminated. Collaboration is critical in lean approach. Strategies like last planner depend on commitments from all project team members for reliability and improvement. Exchanging and analyzing data is critical to collaboration. Teams discuss their understanding of the work and how their work is related to others. As project proceeds, the plan is reviewed regularly. Main features required from a lean construction system are flow, integration between planning levels, and value generation. Construction scheduling is generally done by computer tools that use critical path method. However, these schedules are not adequate for production planning, and field workers prepare their own work plans, which usually consist of work to be done, people, equipment, and material assignments. A general criticism of traditional construction planning is that the practice focuses on management of contracts and costs instead of production processes. Another weakness of the traditional method is the assumption that prerequisites of each work package will be available at the time the work is scheduled to start. However, for a reliable work plan, constraints should be considered and removed before starting any task, most common of them being design, materials, prerequisite work, space, equipment, labor, plan, and contract constraints. Traditional systems view the project as a combination of activities, whereas in lean construction scheduling, the entire project is viewed as a temporary production system. Lean construction scheduling methods are used for improving production control as they support a faster response and reduced uncertainty and constraints. Many professionals start practicing lean construction and scheduling by implementing last planner system. Last planner is the most well-known planning and control system in lean construction tools. Established by Glenn Ballard and Greg Howell, it's a pull system where materials or information is allowed into a production process only if the process is capable of doing that work, as opposed to a push system where inputs are pushed into the process based on a target completion or delivery date. It's based on 4 fundamental concepts: should, can, will, and did. Should sets the goals, can solves constraints, will stands for what is scheduled, and did stands for what's executed. This system is a pull technique that eliminates overproduction waste. It is a creative process that involves the workers in the work planning, since they are the ones that create value for the customer. Last planner starts with a master plan, which is the long-term initial project plan that identifies overall execution strategy for the project. Based on targets from the master plan, a more detailed and manageable phase schedule is formed. Then the master plan or phase schedule is detailed to create a medium-term look-ahead plan that pulls the resources into planning process and shows the work to be done in a time frame such as 6 weeks. Look-ahead plan is more than just a task breakdown. It involves making work ready, and if not implemented correctly, affects the end result. After that, short-term work plan is generated for scheduling of the work that will be done on site. Activities are only committed to the work plan if they can be performed based on the evaluation of specific field conditions. Plan reliability is measured by a metric called % plan complete, which is calculated by dividing completed weekly scheduled tasks by total weekly scheduled tasks. Effective implementation of the last planner improves production performance and reliability, while the workflow variability is decreased. It assists in collaborative planning and improves teamwork and proves to be a dynamic method that provides forward information for control. Implementation results in increased productivity, shortened durations, and cost savings. Work plan is a method developed by Chu and others that adapts last planner and leads users through stages of establishing a quality weekly work plan that represents an element of a more detailed master schedule. Work package is released for construction after all the constraints are satisfied. Work plan guides users through the steps of the planning process that helps the users to work more accurately. Chu and others developed integrated production scheduler, a constraint-based planning tool that also handles resource and information constraints in addition to the process constraints. This model is set to simplify collecting data and reduce inconsistencies in work plans. Sriprasad and Wood developed multi-constraint modeling, which is a collaborative multi-constraint considering construction planning methodology that effectively handles uncertainty. Chu and others developed a plan, which is an integrated approach in design management that has the operational approach of last planner. The plan consists of design planning, scheduling, and control. Davut and Sriprasad proposed LUIS, which stands for Lean Enterprise Web-Based Information System, a multi-constraint scheduling method rooted in the last planner again. They developed a multi-constraint genetic algorithm application in MS project and obtained a near optimum constraint-free schedule. Björn Foth and Yonglin proposed the application of line of balance scheduling in combination with 4D CAD model as a method to improve workflow management. In line of balance method, project is broken down in physical sections and location is considered as a dimension for simpler planning of continuous resource use. Proposed method allows project parties to visualize and simulate work before it's executed on site. Implementation of the model helps uncover potential problems. Sachs and others proposed a building information modeling enabled system based on the last planner called CAMBIM to support production planning and control on construction sites. It's the software system that provides 3D visualization of process status. Use of CAMBIM eliminated substantial amount of waste and improved workflow, resulting in improved productivity. Construction Owners Association of Alberta developed workplace planning, which has become a contractual requirement on most of the industrial construction projects in Alberta, Canada. Main aim of workplace planning is to deliver all necessary resources to the right places and people at the right time to avoid cost overruns and delays and to keep on-site supervision team away from time-consuming tasks to help them focus on supervising their crews. At the end of the projects, lessons learned are documented to enable continuous improvement. Kim and Kim present the computerized integrated project management system whose foundation is a scheduling system that adopts lean construction principles. Material management is linked to a detailed production plan and the system follows the last planner. Implementation of the system increased productivity and accurate schedule planning ability while reducing demand variability, material inventories, and supplier lead time. Heravi and Rashid developed the lean construction plan based on waste elimination. Appropriate lean construction techniques were used to reduce specified non-value added processes. And last planner method was improved using critical chain method as a component of the developed plan. The performance of the studied project was shown to improve by 90%. Implementation of a lean construction scheduling system is a very challenging and complex process because it just does not depend on the method itself, but also how the implementation is organized. It requires significant support for project teams by dedicated facilitators over the long term, which is difficult to maintain. A key step in implementation is constraint analysis on planned activities. Constraints should be identified and removed for making tasks ready for execution. Successful implementation depends on top management commitment and training of staff and workers. Lean construction scheduling is a collaborative process involving many parties, so low understanding of the concept, language issues, and weak communication are some of the barriers of implementation. According to Sachs and others, lean construction scheduling is better at meeting needs of the customers than traditional approach. Benefits associated with implementation of lean construction include reduction in waste, schedule, cost, risk, and workflow variability, improvement of efficiency, quality, processes, inventory control, project delivery method, health and safety, supplier relationship, and stakeholder cooperation. Increase in labor productivity and performance and employee satisfaction, generation of better customer value, reliability, and profitability. Being a collaborative process, social interaction is required. Human is an important factor and system works on mutual commitments. Commitments are composed of design and specifications, agreements, decisions, instructions, and external conditions, socially constructed reality. And as the team work to fulfill these commitments, they build trust with each other. With the trust, reliability, and chance of success increase. Privan and Sachs studied 12 residential projects to measure the impact of the last planner and found that implementation of the system strengthens social networks and communication. It results in establishment of social network connection in different groups where no or little connection would have been established without it. Gash and others studied social interaction patterns of participants of two construction projects, one implementing the traditional system called A, and the other one implementing the last planner called B. Participants of project B had a higher shared understanding about the project, were more cooperative, had higher level of trust in each other, and had higher involvement in decision making. Exchange of commitment was seen to be an important component of project B. Lean construction scheduling methods are used for improving production control as they support faster response and reduce uncertainty and constraints. Last planner is the most well-known and powerful planning and control system among all lean construction tools. Many other lean construction schedules that are developed follow the last planner. Lean construction scheduling is a collaborative process. Social interaction and human is an important factor, and the system works on mutual commitments. As participants work to fulfill these commitments, trust is built, so reliability and success rate increases. Implementation does not just depend on the method itself, but also how the implementation is organized. There is not a formula for adapting a lean scheduling technique, and every project is unique. Therefore, there are many researches about implementation, supporting tools, and metrics to measure the reliability and performance of the system adopted. Applying lean construction scheduling results in cost savings, increased work quality, reduced project time, and less inventory and rework. Thank you.